Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Happy Aloha Friday, 8th grade, and the weekend is almost upon us. So I just want to point out the rugby hat, my rugby hat today. My grandson down in Australia has a big rugby match tomorrow against a big, strong, fast team. But he's big and strong himself. So he's going to run the ball. He's going to be the major runner. They call it the center in rugby. He's going to be deciding whether to run the ball or to distribute it, and they have to pass behind their back. So if you've ever seen rugby, and there's a specific way to pass, kind of a snap pass, and he's really good at it. So anyway, I'll give you a report on Monday about how they do. And their game is, their game is today, actually, because it's Saturday down in Australia. Our Friday, their Saturday. Okay, 8th grade, here are the answers to your test really quick. Then I have 2 guest speakers coming in, and I am going to intro them in just a little bit. John 1:3, I hope you all got it right this time. All things were made by him, and without him nothing was made that has been made. What does it mean? Jesus made everything. Colossians 1:17, what does it say? Everything holds together by Jesus, nothing else. Half a point each. Holds together. Holds together. So I want you to remember that. I'm still trying to do brain glue. That'll probably be on the final. The scientific study of matter is right up above. Look what it says. That's why I said, what could that possibly be? Look what it says. Basic chemistry. So the scientific study of matter, chemistry. Matter is scientifically anything that has 2 characteristics. Has mass, nothing else. Takes up space or has volume, nothing else. Number 6, when 2 or more elements combine, you have an element compound. You've got a compound. I hope you didn't put fusion. Compound. The smallest part of a compound is a molecule, M-O-L-E-C-U-L-E. The smallest part of an element is an atom, not a subatomic particle, not a gluon, not any of the other ons. The 100 plus kinds of matter, elements of course. Number 10, individual atoms are hypothesized to be like or resemble a fluffy cloud. By the way, we've got gorgeous Virga out there today. So let's keep it going. The center of an atom, nucleus. What 2 subatomic particles are in the nucleus? Protons with a positive charge and, protons and neutrons with a neutral charge. What chemical process taking place on the sun? So hydrogen, helium, produce helium. So the chemical process is fusion. And number 13, atomic packing, or how tight atoms are packed, density. The Standard Model involves the fundamental particles. The Higgs field is an invisible field of energy and is hypothesized to give mass, M-A-S-S, to matter. Let's see, 17, 18, the 4 fundamental forces. I gave you electromagnetic, so gravity, and then weak and strong force. The preciseness or precision of the just right mathematical values for the particles show they had to be created or designed. Couldn't be an accident, couldn't be natural processes, couldn't just be material processes. It couldn't be atoms that were doing things all by themselves. Doesn't make sense. Dr. Meyer is going to say in his video, the second video you're going to see, Dr. Meyer is going to say that no reasonable scientist believes that material processes, that means just atoms all by themselves, organize themselves to make proteins out of amino acids. It's just most scientists don't believe that. So some are in denial because they don't want to believe in a God, and they're worried about, if there's a God, he might judge them. Yeah. It's a good thing to worry about. So anyway, let's keep it going. Give one example of the group of subatomic particles known as quarks, protons or neutrons, either one. The LHC, the Large Hadron Collider, is a massive machine that smashes proteins into each other to find out what smaller particles the protons are made of. True that. That's a freebie. You're welcome. The PTE stands for the periodic table of elements. On the PTE, on the left side, over on the left side, metals, metalloids, and nonmetals. So Dmitry Mendeleev noticed a pattern of element properties that he studied on his first ever PTE. Second page, the 7 horizontal sideways element groups are periods. The list 3 of the 4 things in the element boxes. So atomic mass I gave you, you're welcome. Atomic number, the number in the box, the element symbol, the element's name. The atomic number is the number of protons. The alkali metals are in group family 1 and are all very reactive. So reactive, you saw them react on that one video. What are nonmetals like? They're not good conductors of heat or electricity. They're brittle, they're dull. All of those are okay. Name 2 of the nonmetal families: carbon, hydrogen, nitrogen. There's a couple. Radioactive elements, number 1 characteristic is unstable, or they just break apart or fly apart all by themselves. A radioactive element releases gamma radiation, you're welcome, along with alpha and beta particles. A radioactive element releases gamma radiation when it breaks apart. I did that already. Which of these particles is the most dangerous? Gamma. Gamma. G-A-M-M-A. Besides treating and diagnosing disease, how is radioactivity useful to mankind? Making electricity, like at Palo Verde Nuclear Generating Station, west of Phoenix. Hurry, Mr. C. I am. So next, there it is. Valence electrons have the highest energy level. The arrangement of an atom's electrons determines its chemical properties. The arrangement of electrons in an atom also determines how it bonds or sticks together to other atoms. That's a very true statement. You're welcome. Another Moana point. If an atom has 8 valence electrons, it is more likely to be stable and not radioactive. You could use either answer. 2 gases found on the sun, hydrogen and helium. Hydrogen first. 2 gases found in Earth's atmosphere, nitrogen and oxygen. Nitrogen first. Element that makes up plant, animal, and human tissues, carbon. This is a silvery liquid. Hg, mercury. Lots of this metal found on the ground in Arizona. C for copper. Name of the radioactive element Marie Curie discovered: radium, Ra. Very dense metal that's attracted to magnets and rust. Iron, Fe. Very strong but very light metal used in human knee or hip replacements. Don't I know that? Ti, titanium. A metalloid used in computer chips. Si, silicon. Silicon, not cone. Name 1 alkali metal. You've got sodium, potassium, rubidium, cesium, etc. All right, the symbols: iron Fe, carbon C, uranium U, oxygen O or O2, Cu, copper, gold Au, aluminium Al, hydrogen H, silicon Si, neon Ne. So there you have it, the test. Okay, today I've got 2 guest speakers coming in, and one of them is going to talk about proteins, what they are, and then the second one, Dr. Meyer, is going to talk about the probability of one basic protein forming accidentally. One protein of, say, 150 amino acids. It's got to have just the right number of amino acids in just the right location and just the right folding. None of it can be out of place. So And I'm going to prove that to you in a minute. So anyway, proteins are complex chemical molecules in your body that do very complex jobs or functions. You've got about 20,000 different proteins in your body. By the way, you've got your white sheet. You're numbering 1 to 10 on one side and 1 to 10 on the other. It's going to be worth 10 to 12 points depending on how well you do. If you do really well and you don't do little bitty bullet facts, and you do a great job, you might get 12 out of 12. Now, if you don't do a very good job, you won't get 10. You might not get 9. You might not get 8. You might not even get 7. Ooh, that's not good. That brings you down to the D range. Yep. So do a nice job, just saying. You've got anywhere from 80,000 to 400,000 proteins in your body that do all the different jobs, which Hank's going to talk about. All the jobs that proteins do, they do all kinds of things. And there's only 20 different amino acids. Wait a minute. How can you get 20,000 different proteins if there's only 20? Well, remember, if you have a different order of those amino acids, and you have 150 or more, so one amino acid out of order, proteins are made of amino acids. One of the 20 amino acids that's out of order, so got to have just the right order of those 20 all mixed up, and they can be repeated over and over. The biggest one in the human body has 34,000 amino acids in just the right order and just the right folding. If it doesn't have the right folding, then it won't do the right job. So that's why Dr. Meyer says material processes, in other words, chemicals all by themselves, organizing themselves to do all this in just the right order of amino acids. Most scientists are going, didn't happen by accident. It had to be designed. So, proof there's a God. And most scientists believe it. A lot of them won't admit it because they don't want to lose their jobs. They don't want to lose their funding at their university. But in their head and heart, they know there's no way those proteins form by themselves. And they especially know DNA didn't form by itself. No chance. They know it. Many of them admit it and write it in their publications. Okay. So anyway, I want to prove what I'm talking about. Have a look at this. These are red blood cells. Red blood cells. Picture taken through a microscope, magnified of course. Red blood cells. Now the bluish ones you see, there's what, 2 of them, 3 of them? Those are white blood cells. So in your blood, when you get a blood test and you give a little bit of blood, mostly red cells. Now if you look carefully, you'll see most of the red blood cells are round. You see that? You see some of them though that have this shape. It's called a sickle shape. You see that? Look around. There's a number of them that are sickle shaped. Not good. What happened? One of the 147 amino acids that make hemoglobin, a chemical that attracts oxygen on the red blood cell, one amino acid was missing in the chain, and a different amino acid was substituted in its place. There's a mutation, and you know how I've told you mutations are bad. They're rare, they're harmful, or they're fatal. All right, here's proof of that. This blood disease that you're seeing on this slide is called sickle cell anemia. Put your thumb up if you've ever heard of it. People who have this rare blood disorder have these sickle-shaped red blood cells. They can't carry oxygen properly, and they get trapped in the little bitty, not very wide, not much of a diameter of blood vessels called capillaries. They get trapped and it hurts. It's real painful. So, and sometimes this disease is fatal. Mutations are rare, harmful, or fatal. This is a mutation. Sickle cell anemia. One amino acid not there. Just one in the 147 amino acid chain. So there's some scientific evidence for you right there. Now, Hank's coming in. He's going to talk to you about proteins, and you're going to write down bullet facts on what he says. Mr. Phillip will help with that process, and even at the end, help you out. Even stop the video, maybe halfway through each one. And then Dr. Meyer is going to come on the backside, and Dr. Meyer is going to explain the probability of one protein, just of 150 amino acids. That would be a modest protein like hemoglobin, and why it couldn't form by itself. The chance is 1 over 10 to the and an exponent. So look for that. It's a coming. So anyway, 2 guests, Hank, and then you'll flip your paper over and do bullet facts for Dr. Meyer, who pulls his brains behind him in a wagon. That's a figure of speech. He is super duper smart. His big research at Cambridge University in England was on DNA, and he wrote a big fat book on it and on why it couldn't form by itself. So all proof that there is a designing, creating God, and we praise him for all that he has made, especially DNA and proteins. So, all right, Mr. Phillip, if you will start that Hank video. Thank you, sir.